Assalamu alaikum friends, my name is Bilal Khan and this is my 8th video of DevOps. So this video will be started from a HTTP or Hypertext Transfer Protocol. So we have seen in the previous video that HTTP is used for web pages and it is following the process of client and server model. So basically a client will send a request to the server and the server will respond back to the client with the information that the client has requested. Alright? So the HTTP is a stateless protocol. It means that the server does not store the information of client. Alright? So this is the thing that you need to remember, that the HTTP is not going to store any type of information of the client. Instead, there are other things that will store the information of the client. So let's say if a person visited a website and he entered the email or password to log in, then second time if a person visits again, then that information is not required. So where are the information stored? So this is the thing that I will be showing you in the next slides. So where are the information stored? So you just need to remember that the HTTP is not going to store the information of the client. Alright? So now let's move to the next question, and that is, what is World Wide Web? So any page you see online that contains documents, images, videos, audios, objects, any type of information that you see online is called World Wide Web. Alright? So it is a collection of all the web pages. Alright? So let me show you something. Let's close this slideshow and move to the browser. So here you can see that I am in the google.com website. Alright? So let's right click on this, inspect, and after that click on the network tab and let's refresh this page. As you can see that the Google web page is loaded, and here are some of the packets that are received. So in the previous video I have shown you that the data will not be loaded as a whole. Instead, the Google web page or any type of web page will be loaded in the form of chunks or packets. So these are the packets that is collectively form a Google web page. Alright? So let's take any type of packet. Here is a favicon. Let's click on this. Alright? So here, it is the header. These are some of the details that we will be going on after that. But let's take this URL that I have gotten. Alright? So let's take this, copy this, and move to another tab, paste it here. Alright? So as you can see that this is the image of the Google that I have got in these packets. Alright? So these are the packets. So let's say here is a Google image. So if I click on this Google image, open image in a new tab, you will see that this is a image that has a specific link to it. Alright? So every packet will be containing a specific link. Similar, such as this favicon has a specific link. Similarly, this Google image has a specific link. So every packet that is loaded here is containing a specific link. Alright? So this image is also present here. So let's click on this. As you can see that this page has a link. Alright? So after that, let's close it and move to another one. Let's open up this one and copy this link, and now paste it here. Now you can see that this is the link of the image that is loaded with this URL. Alright? So here is the process through, here are the packets, and here are different types of, here are the packet links. So let's move to let's say some of the packets, any of the packets. These are the messages that is get HTTPS host google.com, file name is this, address is this. These are this is the status, version, transferred, referred policy. Alright, and this is the response headers that contains a lot of information, and this is the request header. Alright, So the data that is responded contains this type of information, and the data that is requested is containing this type of information. Alright, so if you want to look into some specific type of information, or if you don't know any the definition of the information, you will simply click on this question mark. Let's click on this. Here you can see that this is the server definition that is appearing here. Alright, so let's click on this and click on this connection. Right, so this is the definition of connection and the details that it is showing me that what is connection and what is the functionality of this. All right. So I will be showing you some things like status or cookies in the later of this video. But you need to remember that if you click on this cookie, the page will load you into the cookie page. Alright, here is the definition of cookie. So what are the cookie? I will be showing you in the next slide. So here are the things that you need to remember, and after that let's close this. And here you can see that these are some of the methods like get, post, get, post, get, post, that I will be showing you here in the slide. So before moving to the slide, let's close this, and before moving you into the slides, let's open up a video. Alright, so here is a video. So here you can see that here it's showing us the domain name www.youtube.com/watch !v is equal to a keyword. Alright, so this is a keyword that is only specific to this video only. Right, so there are a lot of websites, there are a lot of videos that has different kinds of keywords. So those keywords are only specific to that web page only. All right, so let's take a look at this slide show. Here you can see that docs.google.com presentation. So after that, this is the keyword, or maybe this is the keyword. All right, so DID. All right. So this is the keyword that is only specific to this slideshow, computer networking 5. If I open computer network 6, the keyword will be different. Alright. So now let's move to the slideshow again. After that, let's look into the HTTP methods. So method is a way that tells the server what to do. Alright, so it is basically telling the server what are the things that you need to perform. Alright, so here are different methods through which the server will understand that what are the things that it needs to perform. So the first one is the get method. The client will get the information from the server with the help of get method. Alright, so if a client wants to send the information to the server, then it will use the post method. Alright. Similarly, if the client wants to put the data into the server, then it will send the data into with the help of put method. And the last one is the delete method. If a client wants to delete the data from the server, then it will use the delete method. So these are some of the methods. There are a lot of methods also. So if you are familiar with web development, you can understand that what are the methods and what are the use cases of it. Alright. So now let's move to the next slide. And here is a question that when you send a request to the server, how would you know that the request has failed or passed? Alright. So let's say you send a request to the server, then what is the way through which you can understand that the request has whether failed or passed? Alright. So to answer this question, there are the status codes. Alright. So let's close this and show you. I have shown you previously that let's click on this. Let's click on another packet. Here you can see that this is a status code. So this is 304. There are a lot of other packets like 204, 204, 200. So these are the status codes. Alright. So let's close this and move to the slideshow again. Here are the status codes. So with the help of status codes, you can understand that whether the request has failed or passed. So if the status code is ranging from 100 to 199, then this status code will be used as an informational code. Alright, so the status code will show you some kind of information. So if the status code is ranging from 200 to 299, then it will show you a success message. Alright, so if the status code is ranging from 300 to 399, then it will redirect you to some area. Alright, and if the status code is ranging from 400 to 499, then it will show you that the client or you has made an error. Alright, and after that, if the status code is ranging from 500 to 599, then it will show you that the server has made an error. Alright, so this is the functionality of the status code. After that, let's move to another question, that if the HTTP is a stateless protocol, then how the browser know if a user is logged in or not. This is the thing that I want to show you. I have shown you in the previous video, that is in the previous slide, that the HTTP is a stateless protocol. It does not store the information of the client. So how would the browser know that if a user is logged in or not? So it will know with the help of cookie. Alright, so the cookie is a unique string stored in the client browser. Alright, so this string will be stored in the browser, in the web browser of the client. So with the help of this cookie, the browser will know that the user is whether logged in or not. So this cookie will store the information of the user. If you visit a website for the first time or send a first request, the server will send a cookie to the browser. So by the first request, the server will send a cookie to the browser, and that cookie will contain some kind of information. After you send a second request, the request header will contain the cookie, and it will be identified by the server database. Now it will not send the request to the server again and again. Instead, the cookie will identify that information and get the relevant status code from it. Alright, that code will be status code or failure code or any kind of code that the cookie will send. That the status code will show us that the cookie is containing that type of information or not. Alright, so now let's move to the next slide and show you what is third-party cookie. It is also a cookie, but it is not the first-party cookie, it's the third-party cookie. So this is used mainly for advertisements. So the first type of cookie is only used for storing some kind of information, but this third-party cookie is used for advertisements. Let's say you visit a website a.com, alright, and it contains an ad, alright. Keep in mind that this ad is from another server. This is not from the first-party cookie server that will store some kind of information. Instead, this is from another server. There are two servers. One is loading the website, and that is the first-party cookie, and another has no access to the website directly, and it is third-party cookie. All right. The publisher or a person that will give the ad to the website will place a code or script on his website to display an ad. All right. So he will place some type of code on his website to place an ad. When you call a.com, your browser will make a request to the server, all right, and get back a response by rendering a website. So basically, you will send request, and the browser will give you the website. Now the browser will request the ad server to request an ad. All right. So the browser will also request the server to request an ad. If you click on this ad, all right, so the server will be, and the data will be, the request will go to the server that this person has requested this type of ad. So now the server will respond with a third-party cookie. or the third-party cookie will be stored in your web browser, so that it will identify that this person has clicked on this ad. Alright. When you visit a B website, the browser send a third-party cookie along with the request. Alright, so the browser will send a third-party cookie with the request, mainly because to identify that this person is whether this person is the previous person that has requested with the a.com website, or this is a different type of person. So it will take this third-party cookie along with the request. The website server will identify your profile with the help of third-party cookie and make a unique browsing profile for you. Alright, so it will make such a account for you. It will make an account for you that this person has requested from this b.com website, and with the help of this third-party cookie. Alright, so now let's move to another slide and show you how to send an email. So email uses TCP to send the whole data. Basically, in the previous video I have shown you that TCP, or Transmission Control Protocol, is making sure to send the data 100%. It will not allow any data packet to be lost. Alright, so let's say you are sending email from Yahoo to Gmail. It may not be a Yahoo. It is not specific to Yahoo. It could be Proton Mail, it could be Hotmail, it could be Yahoo Mail, any type of email that you are sending between two services. Alright, so how the process will go: first the sender will appear, and the sender will send a message or email to the SMTP server. Alright, so the SMTP server, I have shown you that the SMTP server is used for sending the email. So the sender will transfer the data to the SMTP server. Now the SMTP server is connected to the receiver SMTP server. Alright, so now the data will go from the sender SMTP server to the receiver SMTP server, and after that the receiver SMTP server will give the data to the receiver. Alright, so this is the process that will happen in the sending the email from Yahoo to Gmail, from Hotmail to Gmail, or from Proton Mail to Gmail, or between two services that are different. Alright, so let's say if I want to send an email between the same services. Let's say if I want to send this email from Gmail to Gmail, or from Yahoo to Yahoo, or from Proton Mail to Proton Mail, how it will do this process. So basically, it will send the message from sender to receiver without doing this whole process. Alright, so it will not do this process. Instead, it will send the email from sender to the receiver directly. So now let's move to another slide and answer a question that how to receive an email. So email uses POP3 or IMAP to receive an email. Alright, so in the previous video I have also shown you what is POP3 and IMAP, but I will explain you here that what is POP3 and IMAP. So these are the protocols that are used to receive an email. So the client connects to the POP3 server using the port number 110, and then the client asks for emails from the server. Alright, so basically it will connect to the POP3 server, and then the client will request to the POP3 to give them an email. Give it an email. Let's say here the POP3 is a client, and the client is connected with the POP3. Alright, so this connection is happened, and after that the authorization is also happened, because the email contains the email address or the password. So this client is connected with the POP3 server, and the authorization is also happened to verify that the email or password is correct. After that, the POP3 will give the data to the client. The POP3 will give the email data to the client, and the client will receive or get the data in itself. Alright. So after that, with POP3, you need to remember this thing, that the POP3, the emails are only present in one device, right? They are not present in other devices. So let's say you send an email from your laptop, the email will not be present in your phone, on your iPad. Alright, so other devices will not contain that email. Instead, only your laptop will contain that email. Alright, so how to make it functional that it contains the email in all the devices. So to answer this, here the IMAP Internet Message Access Protocol comes into picture. So basically, it allows you to view your email on multiple devices. Alright, so the emails will be kept in the server unless you delete it. So basically, you will view your email on multiple devices. Let's say you send a request, you send an email from your laptop. Your mobile phone will also contain that email. Your iPad will also contain that email. Alright, so the emails will be present in the server unless you delete it manually. Alright, so you will have to delete it manually. Instead, it will be present in the server. So local copies will be divided in various devices. Alright, so one email will be divided in various multiple copies. So those copies will be distributed in multiple devices. So let's say the email is present in the laptop. The email copy is also present in the mobile phone, and that email copy is also present in the iPad. Alright, so these copies will be distributed in various devices and they will be synced together. Alright, so with the help of syncing, they are, let's say they are connected together. So if one thing happened in one device, the other device emails will also be affected. So let's say you deleted an email from your laptop, the email will also be deleted from your phone because it is connected together. Right? So now let's move to another question, and that is DNS. What is DNS? The domain name system turns domain names into IP addresses, or IP addresses into domain names. Alright, this is the functionality of DNS, that it will turn the domain names into IP addresses and vice versa. Alright, because the computer cannot understand the text or domain names, it can only understand the numbers. So the domain names are for our easiness. Alright, so we will type the domain names and the DNS will convert that domain names into the IP address, and with the help of that IP address, the specific website will be in front of us. Alright, so the DNS server is a computer with a database containing the public addresses. Alright, so it is a server that is containing the public addresses associated with the names of the websites. Alright, DNS acts like a phone book for the internet. So you know that the phone book is containing different types of phone numbers, and with each phone number there is a specific name attached to it. Alright, so if you want to call to somebody, then you will have to look to that phone. Then you will not look into that phone number. Instead, you will first find the name of the person, and after you find out, you will type that phone number into your mobile phone. Alright, so the DNS work like a phone book. Alright, so it will basically contain the IP addresses, and the IP addresses will be attached to the domain names. Whenever people type domain names like Fortnet or Yahoo.com into the address bar of the web browsers, the DNS finds the right IP addresses relevant to that domain name. Alright, so the IP address, with the help of these IP addresses, the domain name will be identified and give the access to that web page. Alright, so now let's move to another slide, and here are some of the domain DNS classes. So here the first one is the mail.google.com. Alright, so the first one, the mail, is present under the umbrella of Google. Also, alright, so the Google is containing this mail subdomain. Alright, so the mail is a subdomain of Google. Basically, the Google is providing the functionality to transfer emails to different services, to different persons. Alright, so this is the subdomain of google.com. Alright, so let's close this one slideshow. As you can see that the just like the mail.google.com, docs.google.com is also under the umbrella of Google. Alright, so the docs is a subdomain of Google. Alright, so there are a lot of subdomains that are present under the umbrella of Google. So after that, here is the subdomain. Now the Google is itself a second level domain. Alright, so this second level domain is attached with the top level domain. Alright, so the top level domain is the .com. Alright, so there are a lot of top level domains like .com, .edu, .org, .io, .net, .pk, .en, .ir. These are country specific, but there are a lot of top level domains. Without these top level domains, these second level or subdomain domains are worthless, because they are they will use these top level domains. These second level or subdomain will use these top level domains. Alright, so all the domain names will not be stored in just one server. Instead, there are multiple servers required to store these domain names. So to solve this problem, the root DNS server will come into picture. Alright, basically the root DNS server will contain all the top level domains and the second level domains. Let's say the .io, .org, .com, .net. There are a lot of top level domains that will be associated, that will be present in the root DNS servers. Alright, and now the second level domains like student, community, Google, so these are attached to these top level domains: student.io, community.org, google.com. Alright, so one thing you need to remember, that the Google community or student, you have to write it manually. You can rent this domain, but these top level domains can't be changed. Instead, these are fixed. Alright, and another thing you need to remember, and that is the .com, .org, .io, these top level domains can only be rented. You can't buy them all. Alright, instead you will have to rent for some amount of time. Alright, so the ICANN will provide these top level domains to the marketplace. The marketplace could be GoDaddy.com, could be Namecheap, could be Hostinger. So these are the marketplace that will provide the top level domains, and that top level domains is taken from the ICANN to the marketplace. So the marketplace has taken the top level domains from the ICANN, and now the marketplace is providing those top level domains to us to rent it. Alright, so we will pay some money for it, and then we will rent it for some time. It may be for 1 month, for 2 months, or for 1 year, for 2 years. Alright, so basically we will rent it, we will not buy it. So these things are managed by ICANN, Internet Corporation for Assigned Names and Numbers. Alright, so this is the organization that is providing the top level domains. Let's close this slideshow, and let me show you this root server. First of all, rootservers.org. Let's just click on this, and if I refresh this page, as you can see that these are some of the root servers that are present all over the world. Let's zoom into it. As you can see that these root servers are divided. Let's click on this one. Right. So now here is Islamabad. Let's click on this. Here you can see that these are present. This root DNS server is present in Rawalpindi, Islamabad, operated by ICANN. These are the IPv4 and IPv6 IP addresses. Alright, so don't get confused by the IPv4 and IPv6. I'll be showing you in the next videos, upcoming videos. So this is also operated by ICANN, and this is operated by Internet System Consortium. Alright, so these are the root servers that are present all around the world. Now let's move to the ICANN. So here is the website of this ICANN organization that is providing the top level domains. Alright. So now let's move to the slide again. After that, here is a question that when you, what happens when you visit a website for the first time? Alright, so basically it will first of all check in your own computer. Alright, so there is a thing that you need to remember, that the website that you visit will first of all be checked in your own computer, because the data will, the request will not be made to the main server again and again. Instead, the computer will check first of all in your own computer. After that, if it is not found, then it will send a request to the local DNS server or ISP to check that website in whether it is present in local DNS server or not. So let's say the local DNS server is also not showing us that website. So let's say you requested a .com website. So it is not present in the local DNS server, so it will send a request to the root server or the main server that will show the that will check for the .com website that you requested. So let's say the root server is also not showing us that this .com website is present with us, so it will send a no message to the local DNS server, and now the local DNS server will contact the TLD. Or TLD, what is TLD? The top level domain. Alright, so the local DNS server will contact the top level domain to find out this .com website. So the TLD will give the IP address of this .com website, and the IP address, the local domain, local DNS server will convert this IP address into the google.com server. Alright, so it may be an Amazon server, it may be an Netflix server. So with the help of this IP address, the google.com will be identified. Alright, so this is the process when you visit a website for the first time. So here are the steps that I have shown you. You can read it yourself. So what we have learned today, so HTTP methods, status codes, cookies. After that, third-party cookie, POP3, IMAP, DNS classes, and after that, a process of visiting a website for the first time. Alright, so that's it. I hope you liked it, this video. If you like this video, please make sure to subscribe to my channel. And if you have any questions, then ask these questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.